Hello, here is a presentation of the project of Group 10. My name is Shakarim and our value engineering project is about waste treatment in citrus juice production. The objective of our project is to improve the waste treatment system in one of the largest orange juice production companies, Citrus BR. Here you can see the current production process of Citrus BR. The improvement of the current system is needed since Brazilian exports of citrus byproducts significantly reduced in comparison to past years. The next speaker will discuss function analysis of the system.
So, the function analysis starts with determination of basic, required secondary and secondary functions. As you can see, for current system, the reuse of orange juice production waste is the basic function. The minimization of carbon footprint is considered as required secondary due to the necessity to follow sustainability rules of the company. Also from this slide, it is possible to observe that 4 secondary functions are demonstrated for current system. System allows further application in confectionery and cookery, enhance variety of produced goods, generate components for perfumery, cosmetology and household chemistry, and reduce unemployment due to workers required. The cost and worth for each of function are also represented in the table. It should be mentioned that the worth for secondary functions is 0. The value index for basic function is 0.81, which is acceptable. The average with required secondary value index is not calculated because both cost and worth of required secondary function are included in the cost and worth of basic function. Therefore, the value to the system should be added. Next, the fast diagram will be demonstrated and discussed.
Now, by concentrating our attention to the next slide, it can be seen a schematic diagram of the blocks which comprises ordered functions on it. This diagram is known as fast diagram. Actually, a fast diagram is divided into 3 parts, which starts from input, follows by critical path, and then ends with output function. Here, critical path refers to the waste treatment system of orange juice production. Each ordered function, which are linked by the critical path, are placed with the logic sequence. This sequence is generated based on the questions why from right to left and how from left to right. For instance, why waste should be collected, the purpose is to utilize waste and in the same manner for the further steps. Special parameters of the process will be found on the upper region of the diagram, where dashed blocks correspond to design criteria that should be undertaken into account during pathway. In this case, they are generate profit and utilize overall waste, whereas upper region blocks stand for all time functions that should be met, such as health and safety standards, reduce carbon footprint, and conserve energy.
The cost-worth model for the original system, in our case, is the citrus pulp pellets, is divided into 4 sections. They are mechanical, electrical, equipment, and general spendings. From table we can observe that the general spending has the highest expenditure needed to maintain the project cost. This is due to the high labor transportation expenses. The equipment cost needed for the production of pellets is $178,940. This includes dryer, shredder, steel tank, press filter, dopants, precipitations, and distillation equipments, whereas the estimated worth value of the equipments is $77,200, which is pretty low compared with the actual outlay. The reason of such difference could be due to the quality of the equipment products. The total cost of the system is $621,440. This includes all building, operational and maintenance costs, while the worth of the system is estimated as $342,740. The calculated value index is equal to 8.81. This in fact implies that the total cost allocated to waste treatment is relatively ideal. However, some value to the function could be added and the cost of the system is possible to decrease for more idealistic form. Therefore, this important industry field of the system should be readdressed by introducing new functionality.
Our group came up with this list of possible alternatives of using orange peels. From this list of alternatives, it is evident that some of them could be selected as more acceptable due to the preference among the others, because of the amount of orange peels that are used and the profit that could be achieved. To select alternatives that have the potential to bring the value for the system, several methods was used. First of them is looking for the advantages and disadvantages of each other. The most valuable ways of using orange peels are the following. Firstly, composting production for the agricultural needs. Orange peels make great composting material because they are rich in nitrogen. In industrial scale, its production requires the relatively cheap equipment, small amount of energy input, has long storage life, and intermediate profit. Production of orange compost is eco-friendly, however, it requires long production time demanded only in agriculture. Second, cosmetology production. The scope of these alternatives begins in making of handmade soaps from orange peels and ending in production of famous cosmetology products due to smell and other specific properties. The advantages are moderate income, client attractive, long storage life, low carbon emission. However, the disadvantages include the significant energy and water usage, equipment and material cost, and it's risky due to use of chemicals. Snack production. It's one of the famous ways of using orange peels. Snacks could be made even at domestic conditions with limited sources. It's easy to produce, also beneficial for human health, eco-friendly production, and highly demanded. The disadvantages occur only in industrial scale, which include large amount of water and energy consumption, additional material required, and equipment installation. Jam production. Initially proposed as the main alternative of our group. The advantages include the large profit, long storage life, high demand in market, enhance the immune health, moderate carbon emissions. The disadvantages are evaluated also in industrial scale that include equipment installation, significant water and energy use, and require additional ingredients.
The ranking method is the evaluation of each alternative. Here, the group members have chosen the range from 2 to 8. Each alternative was evaluated by every team member and the average was considered. According to this table, the alternatives with the lowest ranking were excluded from further evaluation. They are disposal of waste, use of it as fire starter, sell for confectionery as preservation of brown sugar, and use as protection from slugs.
Criteria weighting method analyzes and clarifies the distribution of points between the alternatives, the profit to the company's economy, energy consumption, cost, satisfaction of safety rules, and demand in market are chosen as criteria for evaluation. Row scoring is the sum of level preferences. According to the table, the biggest scores calculated were for composting, snack, and jam production. These alternatives were chosen for the further analysis. LCC table shows savings for the original and 3 alternative methods for the orange peel waste treatment, which are food for domestic animals, jam production, snack production, and composting production. It is important to mention that project life cycle was calculated for annual worth. Discount rate was taken as 18% according to the top global statistics source. All costs, including capital costs, salvage costs, maintenance costs, in average were estimated for 10 years, since it is the average time of equipment operation before decommissioning. According to initial savings criteria, jam production alternative was estimated as the cheapest compared to other alternatives, namely snack production and composting production. However, further analysis showed that the composting production was the most suitable since it has the highest annual worth and the lowest life cycle savings. The value index, which is cost over worth, is equal to 1.83, pretty small value index, and which means that it is very good for project initiation.
Moving to the conclusion, here we presented the list of made workings. Here you can see SWOT analysis, which is strengths, weaknesses, opportunities, and threats of composting production. The strengths of composting production are that it is environmentally friendly, allows large income, has long shelf life, and has safe production process. The disadvantage is the low demand of products in the market and bad odor of the products. The opportunities are production of unemployment in rural areas, development of gardening, improvement of soil structure, and reduction of pollution. The threat of composting production is an unpleasant smell effect to the environment. Taking everything into consideration, the composting production is the best solution to the problem. Thank you for your attention.